Hello, welcome to the show. It's me, John Park. We are here for John Park's workshop. If that's not where you intended to be, then you got on the wrong flight, and I apologize for that. But we have a fun show in store, and by we, I mean me and Lars back there, maybe. Cool project build I'm going to be doing today. I also have a pretty nifty CircuitPython parsec to show. I'm glad to see Foamy Guy is in the chat because this pertains to Tim. Tim, Mr. Foamy, the foamiest of Foamy Guys. What else have we got going on? I'm going to show a little recap of a product pick of the week from earlier this week. If you're wondering who I'm talking to, well, I'm talking to all of the viewers, but also our Discord chat, and I can also keep an eye over on YouTube. But if you're in Twitch or Facebook or another place and you're wondering where the chat is, you might want to check out either the YouTube chat or our Discord, which is at adafruit.it/Discord, and you can head over to the live broadcast chat channel. That is where it's happening. Let's see, what else? I've got some delicious iced coffee. I also have some water. It's hot here today. And hello to Jim Hendrickson, Andy Calloway, OK, you're on Steve, Paul Cutler, C. Grover, I see you all, Rich Sad over in our chat, Gary T over in YouTube, Franklin, hello, and thanks for stopping by. Let's see, what have we got? What's happening first? I should mention we have our jobs board over at jobs.adafruit.com. You can go check that out if you are looking for work, if you're looking to hire someone. Wow, that window's super big. Let me make that a little slightly smaller. There we go. That's jobs.adafruit.com. If you sign in, just log in with your Adafruit login, you can go over to the available for hire section, look at resumes, people who are looking to get hired, also add yours to that if you want to throw your info up there, or post a job if you're looking to hire someone. It's all entirely free. So it's a really good place to find people or be found for maker, hacker, engineer types of jobs. And that can be anything from contract positions, full-time, part-time, remote, on-site, and everything in between. So that's at jobs.adafruit.com. Go check it out. Let's see. Also, I mentioned, hi Mike P. I mentioned, hey Todd Bot, who says hello to everyone but John Park. My gosh, that's pointed. I bet you feel bad now. Oh, and hello to Just John Park. He's covering all bases. Thanks, Toddbot. Well, this right here, this little logo, this is, let me make it this big logo right here. That's JP's product pick of the week. I've made it bigger than it really wants to be. Sorry, logo. That happens on Tuesdays at this same time, so 1 o'clock Eastern time on Tuesdays. Every week I show a new product pick or a product from our archive, our vast archive of products that are up in the Adafruit store. Do a little bit of a demo, go over some of the specifications, and you get a big, humongous discount during the show. There's no coupon code or anything like that. This show, or that show rather, is broadcast from inside the product page. And I do a little bit of a recap, and you can check that out right now. It is the right angle lux sensor, VEML 7700 with Stemma QT. This one has the sensor mounted parallel to the board instead of perpendicular to the board, which means you can fit this in some tiny little areas. Since this is mounted at this angle, I should be able to stick this inside of my little box here, and you'll notice it's just peeking out right there. You can disable that LED, by the way. So it's just peeking out there, and we're getting, just from my ambient lighting in the room, about 35 lux. And as I put my hand over that, it gets pretty dark, down to 1. So you could use this for detecting objects, particularly for things like security things, puzzles, escape room stuff. I always like things like that, magic tricks, if you want to have it mounted fairly discreetly. The right angle lux sensor with Stemma QT. Yes, that was it. That was the product pick of the week. So tune in again next week for something new. In fact, we have a double pick next week. Two sort of variations on one product are going to be both available. Two different PIDs, product IDs that will get the treatment there. So tune in next Tuesday for that. Next up, let's do a CircuitPython parsec. How about? Let me get all set up for that. Here we go. All right, getting set up here. What I wanted to do on the CircuitPython parsec today is start to introduce Vector I/O. Vector I/O is a lightweight 2D shape generation library that works side by side with Display I/O. Now we can already create shapes using Display I/O, but these are designed to run faster, take up less memory, and they also are a little more efficient in that in the case of this circle, it really only refreshes the pixels where the circle are rather than a sort of rectangular bitmap of where the circle exists. This is brand spanking new stuff. If you've been tuning in to Foamy Guy's Deep Dives with Tim, he has been working on these as well as some interesting helpers that are on the way or in progress. But for this basic example, what I wanted to show is how you do it. So I'm importing here the Display I/O library and then Vector I/O. I then set up the display and I'm setting up a couple of palettes, and this is actually in a state of flux right now, so we'll be able to do this differently pretty soon. But right now I'm setting up two palettes because I want to use two different colors. And then I'm setting up some coordinate space here using the screen's width and height, and I'm using that initially to set this circle halfway across and a quarter of the way down the screen. Now I'm setting up a variable called ball rad, that's the ball radius. Right now it's set to 13. How about we update this? I'll make this a radius of 20. And then here's how I create it. Right now we have sort of three things we can use inside of Vector I/O. We have the circle, we have the rectangle, and we have a polygon. Today I'm just going to look at circle and rectangle. So for creating the circle, I do vector.io.circle, and then I tell it which color to use from this palette, the radius, and then an X and a Y position. Then I'm doing a similar thing to create a paddle, as if we're doing a little breakout type of game. And that's a rectangle, again with a color, a width, a height, and an X and a Y position. I'm deriving those from the positions of the ball. Then if I append those to the main group of Display I/O and hit save here, it's going to refresh. In a second it's going to redraw, and now it's going to have this new larger radius. Now, to show that these actually run pretty nice and fast, what I'll do is update my code here so that I am using a little bit of code that ToddBot provided, and this is a sort of a little bouncing ball algorithm that reverses or inverses the X and Y position whenever we reach one of the extents of the screen or the top of the paddle in this case. So you can see it's running really nice and fast. I'm getting a little bit of a shearing effect, so what I'm going to do is I'm just going to make the ball a little smaller right now, and this will give it a little better chance of running quickly and without any kind of shearing that you'll be able to discern. Actually, any shearing you're seeing is going to be based on the broadcast and not the screen itself. So this is running right here on a Feather RP2040 and the TFT Featherwing, but this should run on most of our boards and displays, including ones with built-in displays. Now, this is just a really, really preliminary look at how to create a couple of the primitive objects, and I'll be doing more with this in the coming weeks. But that is the basics of how you can use Vector I/O to create a circle and a rectangle inside of CircuitPython. And that is your CircuitPython parsec. Wow, wow. Just checking the chat here, and yeah, there's C. Grover says we need some donuts and arcs. That would be nice to get other primitive shapes. And I was also talking with Tim about possibly adding transforms such as rotate and scale, which would be really helpful. In fact, you may have seen I was showing an example. I think I showed this other example. I'm going to open this up real quick. Circus code 3, sure. Let me open that up and resave that as code.py on the board here. This is one where I'm using some of the other features, and I'll make a better demo for sort of the basics of explaining these. But things like those flags are, I've got those set up as polygons with 3 sets of points. and I have the helper object that creates lines with varying thickness, and I'm using that for the string. And I'm also using the polygon object to create those little sort of trapezoids at the bottom that are like little bases. So the current method of creating those, if you take a look at my arrays of points for the flags, for example, you can see here I've got flag 1, and then I have 3 points, X, Y, and Z, 3 points, and it fills the fourth edge for you, but it creates the points and the edges and the shape. These are difficult right now to come up with those points unless you're using some graph paper, or I used another piece of graphics software to create triangles, duplicate them, rotate them where I wanted to make that arc, and then I just transcribed the points or spat out the points from Rhino and Grasshopper. But the idea would be, it's kind of straightforward to make on a grid a sort of normally oriented triangle, and then we'd like to use some pivot points and rotation calls to move those around the screen. So that's some stuff that Tim has been working on, and I think if you head over to the CircuitPython dev channel in our Discord, you'll see some example, both graphics and code that Tim has been working on for those, which is nice. Let's see. All right, so that's the little extended version of what's going on there with our vector I/O. So very excited about that. Let's see, what is up next? So I want to do a bit of a build today, a kit build. And this is, you may have seen this on Show and Tell. I'm going to bring up my, let's see. Oh, by the way, before I move off of that, here is the read the docs about Vector I/O. And so if you want to get more info about that, you can head to either the library in GitHub or into our read the docs and look it up. And that tells you the basics of the circle, the rectangle, the polygon, as well as setting it up with the palettes. So you may have seen this telephone ringer that Andrew of Make It Hackin' has demonstrated on Show and Tell a couple of times. And the issue here is that a telephone, a standard telephone, old-fashioned standard telephone, has a couple of big bells and some magnetic coils, like solenoids, that are used to move a clapper to ring those bells. And the standard for that system is a pretty high voltage AC with a sine wave at 20 hertz to ring a US phone. So that is the standard. It's anywhere from 60 to about 105 volts AC. 20 hertz sine wave is what makes that clapper move back and forth. So this is not something that you can easily create just by hooking up a battery or the pin out on a microcontroller if you want to use the original hardware. And so, in fact, if you look at the ringing telephony page on Wikipedia, it'll talk about those stats. It'll also go into a little bit of info about the ringing generators that exist at the telephone stations, substations, as well as magenta boxes that phone freaks came up with in the 70s and 80s to ring phones for fun and maybe for profit and doing bad things as well. Phone freaks being phone freaks, as well as a really typical usage of a ring generator, which is theatrical productions. So if it's something like a stage show, or you're trying to ring a bell on when you're shooting a video, doing film or television, in order to ring a phone on command, you kind of need a box that does that. And if you look around, there are some commercial versions of these things that are really geared particularly towards theatrical stuff, to ring phones on stage on command, maybe multiple phones, maybe different types of ringing, long ring, short ring, US ring, British ring. So there are different needs for ringing phones, and what Make It Hackin' has come up with is a CircuitPython and Arduino or Arduino controllable circuit board that uses a feather to control a motor driver through a voltage boost converter. And so this is the telephone ringer circuit board that Make It Hackin' sent me. And this is a revision 1.2. There was a 1.1 that had a little issue with lacking a ground, I think, for the feather. So he very kindly just sent me that one, and I wanted to start putting this together today. If you, let's see, if you take a look here at this, this is the Tindy page for Make It Hackin'. If you just Google Make It Hackin', you'll find him on all the social media. He doesn't have it for sale quite yet. I think it's coming soon, but there are some other neat-looking little DIY projects on there. But this is the GitHub page. So this is at github.com/makeithackin/telephone ringer. This goes over the little bill of materials that we have, as well as some schematics, some notes, and some code. So I have, all I've done really is soldered some header pins onto a feather and put the CircuitPython and the code and the libraries on there. The rest of it we're going to go ahead and just build. So let's jump over here and get going. And what I'm going to try to do is put my Discord page up on my iPad over here so that I can see what's going on in the chat, as well as the sort of build guide for the ringer. So let's go back to, here we go. Oh, sorry, Leon LRYT said, thanks for making this broadcast early, but I have to go to sleep a little bit sooner or at the weekend. That won't be perfect. All right, goodbye. Thanks for stopping by, at least briefly. And you can always catch this in replay. We immediately archive our shows and then play them back later. Okay, so what I've got set up here, here's our sort of bill of materials. So I have a feather. I have our motor controller. This is the DRV8871. Zoom in a little bit here. And let me see if this light helps. This might be a little... You know what? I'll save that for when I'm soldering if we need it. So this is an H-bridge motor controller. So this can send essentially in two directions the sine wave that we need to control the ringer. Normally this would be used to drive a motor forward or drive a DC motor backwards, but this is going to be used to generate that sine wave that rings the bells. I have a little piece of Rj11 telephone cord here in case I need to test something, such as the pin out or the voltages that we're sending. And then the stuff that Make It Hackin' sent, a cool sticker, thanks for that. This is a DC step-up that'll take our, I believe, 3-ish volts, 3.3 from the feather, and bump that up to the 40 to 60, I think, that we need to make this work. We'll see. I think there's a trimmer pot on there to tune that a bit. And then here's all the rest of the parts. So we've got a nice little OLED screen for different modes. There's some buttons and switches for ringing in different modes and switching some modes on and off, as well as some little status LEDs and a few resistors, and then the Rj11 Jack to plug the phone in. So that's what we're starting with. And what I'm going to do, so this can be run off of, I believe it can be run off of the USB on the feather, or it can be run from a battery. So I've been charging, actually it looks like it's just finished charging. I've been charging up one of our little 400 milliamp hour batteries that fits nicely under a feather. And that's because this revision of, or actually both versions of the generator, yeah? Oh no, this revision, previous one didn't have that. This revision has a spot for a feather wing, in case you want to do a side-by-side feather wing with who knows what. But to allow for that, I'm using one of our batteries that can fit under either the feather or the feather wing there. So what I'm going to start with is I'm going to solder in some short feather headers, and I happen to have standard header pins on here. Let me zoom in a bit. On the feather, so this won't go all the way flush, but it is enough space to fit that under there. And so, in fact, to make my life a little easier with soldering that, I'm going to place the feather there. I I'm going to get a soldering iron up and running here. I got one of these little USB-C ones here with the digital readout, nice and fancy. And I also actually wanted to show a nice little life hack here. I have one of these little caddies for the soldering iron holder and a spool of solder, and I have this nice solder iron tip cleaner. I put a magnet inside the base, and now it sticks to this nicely so it doesn't slide around when I'm wiping off the tip. So that's a little hack I just came up with. We'll see how that goes. So to start with, what I'll do is get those headers in place. If anyone sees me doing something silly where you're like, wait, if you do that now, you'll never finish this later, tell me, because I haven't put this together before and I haven't thought it through too much, so it's always possible to put bigger parts in too soon and make your life difficult. So let's turn that little light on there. Okay. And let's get this started. I'll usually solder in the corner pins on these to get going, and then you can just double check that nothing is super wonky before you go soldering the rest of the pins in. So that looks good. My feather itself was in a little crooked, but it doesn't matter. The little feather headers are on there nicely. So I really love this this design. It's a cool, sort of puts it all on one level, one layer, and since the feather is small but super capable, it gives us a lot of room to work with, which is great. So I will not take a pause to clean flux off or anything, because I want to try to make this build as quick as I can. If it seems like we're not going to get it done effectively in time, I will finish the thing offline and show you the results next time. But my hope is, if I'm not being delusional, my hope is that we can get this built and tested all in one show. I have hastily just bridged some points there. There we go, that looks good. Okay. So there we go, that's our first step. And next thing we'll do is the driver controller, the motor driver controller. So this has header pins that connect it to the board, and then it uses these little terminal blocks, usually to connect things to them. It's not really necessary in this case, but it is the design. I think what Andrew has this set up as, looking at the pictures, is some small jumper wires running from the board up into those terminal blocks. I think you could also do it just with a straight wire shot down through there, but I'll do it this way because that does give us the opportunity to plug other stuff into that, at least for testing. Franklin asks if I'm using lead-free solder. I'm not, actually. This is some leaded stuff. I think, yeah, 60/40 leaded. I do have fresh air coming in from my AC. Sorry, I just realized this light is in the camera view, which isn't great. Let's take that like that. And I also have a small little fan drawing the solder fumes away. I will try not to lick my hands. I should probably not even drinking this. But let's see. Okay, so the first thing with the motor controller then is to connect the terminal out blocks and the header pins to that. So we'll start with these header pins. They are 4 of them, and it came with a little strip of 6. So I'm just going to snap off those, And that can go in like that. Again, you could use a header. Actually, I think I will. You can use a strip of headers to connect that to the board non-permanently. It keeps everything agile. So what I'll do is take some somewhat janky cutters. I've kind of dinged these up, and I'll snip this right at the 5th position there, and then just trim off the extra plastic. And now this will give me a little 4-pin. Oh, I didn't count right. Let's take one more off of there. So that'll give us a 4-position socket to mount like so. And then we'll be able to place this in like this. So in a case like this, you can tape these down. You can use some blue tack. You can use a rubber band. I like to often just hold it with my finger and then try to solder the first one in place with the solder like wrapped around a little holder. So let's see. I'll use this one. So I'll take a I have a magnetic base on this. Let me find something strong enough to hold it up. There we go. So I have a magnetic base and a little magnet holder, and I'm just going to hook my solder to that. Whoops, everything falling over. Stay. So now I can have a free hand to hold the board and the little header pin like that. Move this under the camera a little more. Hey, Johnny Bergdahl, nice to see you. We are, if you're just joining us, putting together a telephone ring generator. This is a kit from Make It Hackin' that uses a feather. And there you go. In this case, I can just get the first one started on there, and then I can get this out of the way. I'll just snap off some of that solder and leave it connected to the hobby hands holder there. So now I can place this back like so and solder the rest of that in place. By the way, if you're ever soldering stuff and you're wondering why one pin takes forever to heat up on your board, that's probably a ground plane. The ground plane will actually suck off a lot of heat. Okay, so now we have the socket in place for our motor driver, and now I'm going to take the motor driver pins, motor driver, and solder those into place. Again, this is a case of yeah, I think that's as close as I can get with that. This is a case of you need more hands than you have to do this sort of thing unless you prop things up somehow. I'll look briefly and see. Yeah, if I jam this little, just a little wood block in here, I might get it to hold it level for a second. And now I can get at least one pin going. And by the way, the reason I brought that up about ground pin, if I'm trying to get one sort of dicey solder joint started, I will pick something other than the ground pin, because that one's just going to take more time often to heat up and to cool down to set the solder. Okay, so that looks good and looks square enough. You could use the short feather header pins if you wanted to make this smaller. I often do with projects if I'm trying to make them compact. This one I don't think needs to be all that particularly compact, so I'm using the standard size header pins. Yes, blue tack, super helpful. Absolutely right. Hi, Liz. Nice to see you. Said, I've never seen that technique for starting off a header, taking note. Yeah. Share your techniques. Everyone comes up with ways to deal with these things. Okay, so that looks pretty good, and now I can solder the terminal blocks into place. So these are going to be up top. Not a bad idea, by the way. Before I did the show, I did a little bit of a dry fit of things to see, to try to predict any things that might be in the way of other things. I didn't do it too thoroughly, but this Rj11 Jack, that fits in. Wrong one. Oh, that's a vertical one. Does that one even go on here? That might be a bonus. Here's the one we need. So this will go on right here. And so I just kind of want to make sure that one of those things isn't in the way of another, but since this is on a removable header, it's going to be pretty straightforward to do it in any order. But here's the case, this header here, is there anything there that needed to be soldered that's tricky? That's going to be the boost converter, which is going to go there, and that's just on 4 header pins. We could again do some removable stuff. I might do that. It's not, it's not as secure. It's more secure to just solder things straight to the board. So it's up to you if you want to use sockets for everything. Okay, so that should work out fine there. You know what? I'm going to turn down this AC speed of this fan. Yeah, that's fast. What about that? Is that slow? There we go. Sorry about that. It's just running colder than it needs to. Okay, so let's do these little terminal blocks. They're a great candidate for some blue tack. If I can find where I put my blue tack. I think I was running low. Yeah, I put it somewhere smart. Did I put it in a drawer over here? Is it in one of my tape drawers? No. I have lost the blue tack. All right, that's no good. So I'm gonna do something a lot of us probably do, which is just the holding it with one finger, using your pinkies to hold the solder. So I'm gonna hold it like this. Bend that down there. Try not to burn myself. This is a totally legit method, I promise. You do want to be careful you're not touching the top of that terminal block, because that will get hot. Okay, that's good enough to hold it. And now let me get yet another holdy thing. These are great. These are on a magnet. And I have a steel part of my workbench there that I can connect to. You'll see that here. So I'm just gonna, I've got a little silicone rubber on the alligator clips there too, so it doesn't mar things up. Okay, so sorry, that's not gonna be in super great focus, but it'll be pretty quick, just putting in terminal blocks. And let's grab the other one. Okay, same sort of thing. Holding the solder and holding the block from underneath. All right, so that's done. Okay, so this is going to go in like that, and then the two, you can see this down here below. I think, I got to double check because I've got a, oh, spot of super glue. That's a good idea, Franklin. I got to check the, build from make it hack into C. I don't think there's another, I don't think there's another terminal block. So this is just some wire running up from the PCB up to these here. And again, by putting it on a socket, it makes it a little easier to solder some wires in of kind of the proper length. He sent along a little piece of wire, might as well use that. And, oh, that's the PDF. Hold on, I want to open the PNG file. Yeah, those are just wires running up from there. So what I'll do is I'll strip a little bit of wire. Oh, you know what? This is stranded. I think I'll use some solid core. That might be a little... although, now that I say that, the stranded will probably work better in this terminal. All right, so we'll do that. So I will actually put one of these in, being careful not to let the strands separate, and screw that into place. And then I'm just going to determine how long to make that. So to about there. So let's snip like that. And I'll take this off and I can cut some equal lengths of wire to that. And I think we just need 3. See if there's a good picture. I can't quite tell from there. I can check the PDF. For some reason, my iPad doesn't want to open that PDF, so I will double check that. I might as well make 4 wires. I don't think that can hurt. If anyone wants to check that, GitHub, make it hackin' telephone generator. Let me know. And I'm just going to test this length and this amount of insulation stripped to see. Yeah, that should work. I think that'll work. Okay. So I'm just going to make them all like that. I'm going to put them all into the terminal blocks. Then I can fit those in, hold them with this, and flip around to the other side to solder. Set the little wires there as I go. I used to know how to split my iPad view into 2 apps, and I don't know if they changed something or if I just forgot. But it would be nice to see Discord and my Safari at the same time. By the way, if you're concerned about frayed ends and of stranded wire and your terminal blocks, I do like those little ferrules, those little wire ferrules that you can crimp. That gives it something to squish down against, which is what the screw terminal wants to do. Those are nice. I used those on that other phone, one of those other phone projects. Okay, so now I'll just connect these. By the way, sometimes terminals come all screwed all the way down and you have to unscrew them to open it up enough to feed some wire into. I suppose I could have gotten these even more precise by not stripping and making the cut exact until I put them into the terminal, but I think this is going to work out. It's pretty close. Okay, so now I'm going to feed these. I'm going to actually retwist them so they don't fray. And now I'll try to feed these into their relative holes in the PCB. There we go. Let's see if I can. There we go. Okay, so now I have a nice little connection to the board. Like I said, I don't think all of those are necessary, but I also suspect it'll be okay. Andy Cowley says, I hate the ones with those spring things inside. I never know where I'm supposed to put the wire above or below. I agree. Yeah, those are maddening. Okay, so these, I can tilt this a little bit so you can see what's going on. These right here, I'm going to solder. This little, by the way, this little soldering iron is neat. It does, however, have settings for cool down that I probably can adjust and never have. This thing even has like flashable firmware. I think it's a STM32 or something running these. And so this one is cooled down, but it does heat up pretty quickly. Okay, so we'll solder these into place. And then I will trim those with my beat up diagonal cutters. I don't know what I cut with these that I shouldn't have, but they've got all kinds of nicks and dings. I tried to smooth them with a file, and I think I made it worse. Okay. So motor controllers in. Let's go ahead and do the boost converter here. So this, I think I'm just going to use some header pins in these. I don't know if these are spaced to be able to keep a strip with, I'll show you what my idea is. This doesn't always work out. It looks like it will. Okay, so what I'm going to do is snap off a section that fits, even though this only has, I went one too far again. What do I need? How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. One too many again. Let me break one off. Attempt to break one off. There we go. And then I'm going to yank out the middle pins that aren't needed, just because this gives me a little bit of a better structure, rather than snipping individual ones, which just become a big pain to solder. So I'll try to yank out these middle ones, like so. Okay, so now I have this little goalpost that I can place like that and into the board. Should fit. Ooh, that's a tiny, yeah, there it goes. Okay. Nice. Okay, so that's how all that fit is just a little tight. You can see it's kind of trapezoidal. But if that will let me, will it? No. Yes. Okay. Let's see if it'll really work if I do both sides like that. Let's find out. I might need to shimmy it into place. Also, I can temporarily pull that boost converter out of the way. So let's make another one of these little goalposts. pull out the... Sorry, I can't really do that on camera without knocking over some lights and things that are sitting right here. There we go. I may see if I lift it up a bit before putting it in, that might make it easier. And which way is which? I think in is in. So get that right. It also says it on the top. That's good. There, and there we go. And now we can press that in. So again, we could have gone all the way and used sockets for that, but I don't think it's necessary. I'm going to use that converter right on the board. Hey, Make It Hackin' has arrived in our chat. Thank you so much for showing up. This is a really nicely done board. By the way, really nice and thick PCB. These are impressive. You could use the spares as a coaster, I think. So just to catch you up, I've done standoff headers for the boost converter. I don't think I need all 4 of these. I think that's an extra wire there, but I just happened to put it in. I don't think that's used, but tell me if I'm wrong. And so I can press that in like that, but I'm going to go ahead and solder down boost converter to some header pins there just to get it in place. And Make It Hackin', thank you so much for this board. Okay, here we go. One question is, what are the specs on this boost converter? What's the input and output range that it can do? Okay, so that connects the boost to the tops of those headers, and now I'll flip it over and we can connect that to the board. Put it in like so. Make it happen so 2 of those wires are not used. And I'm assuming it's okay that I've connected them. It won't hurt anything. So this, by the way, I'm going to end up trimming these header pins. They're really, a lot longer than they need to be. I'm going to try to get them down pretty flush. This is the kind of thing that I ruin my little cutters on, and even thicker stuff. But header pins are pretty thick. And where are those? Okay, so let me take this out and show you. So these excess. And wear safety glasses or any kind of eye protection when you snip those, because they come off at 1 billion miles an hour. Also, there are some mounting holes on here, which is great. So if you end up wanting to mount this inside of a project box or something like that, that would be terrific. All right, it's looking cool. And let's see, I probably can do from here kind of smallest things from the middle on outward. So I'll do these resistors and then the buttons and switches and then this display and these biggest buttons. You could get away with kind of any order on these, but that's how I tend to approach it. So these are 10K resistors for the buttons in case your microcontroller doesn't support that. So I'm going to take, these are the spacing on these is going to be basically as tight as you can bend them, which is one of my favorite favorite choices by footprint designers, because it makes it easy to just bend your resistor legs by hand. So these are 10Ks. I verified that with a multimeter earlier, just because it's sadness when you have to replace resistors because you put the wrong values in, or any part for that matter. So these will go in like this. I am in the habit, particularly from synthesizer modules, of soldering things like this from the top if I can. These don't have huge pads on them, but if you can see here. Oh, and by the way, one thing I wanted to try, and I might mount this if it actually is helpful, is using my magnifier app on the phone if it doesn't have too much of a glare. So if you can see that here, let's go to that. Where is that? There it is. Okay, so let's move everything. And there. Can you see that well enough? Yeah, I'd have to refocus. I don't know if that's worth it. Maybe another time. But if I mount the phone on a little mount arm, you might be able to look through that. But just imagine you're seeing a resistor get soldered in place. So I'll do this from the top, just because then I don't have to worry about flipping stuff over. It's a little easier, I find, in some cases, especially for things that want to fall out. These resistors won't, because of how tight the legs are bent in there, but there's no reason you can't solder things like that in from the top. Okay, so that's 10K. There's another. Todd says, ruined cutters. I have 2 cutters, one really nice pair for trimming delicate things, and now one crappy messed up pair I use for snipping big terminals. Yeah, these are really pretty wrecked. I made them so much worse trying to file them. Okay, resistor number 2. If you want to get a lot of practice at surface mount or through hole, there's a lot of great synthesizer kits that I've built, especially things like the company Bafaco modular synthesizer kits that are, boy, you'll get a lot of soldering practice building one of those modules. They just have so many parts. I built I think it's a 6-channel VCA mixer that was a gazillion parts. Tolerance bands on the left or right, OCD question. I've done them wrong. I prefer to put them on the right. I put them on the left, but I'm at least going to keep them same, self-same, consistent. Good question. So what C. Grover is referring to there is the color bands on the resistor that tell you its value and its tolerance. And since I tend to read that, and a lot of people tend to read that left to right, if you're really particular, you'll kind of want to put them in the same direction. It makes them easier to look at and know, oh yeah, those 3 are all the same. So I have the gold band, which is the tolerance, which is what, 10%? I think that means it's within 10% of the color code, so 10% of 10K in this case. Okay. And now I'll do these 1Ks here. There's 1K, a pair of 1K resistors here. There's also one up here, and these are for LEDs. There's some status LEDs. So here's my 1Ks. I measured them, marked them. Actually, Andrew marked the 10Ks, I think, which makes it pretty clear. The others are the 1K because there's only 2 values of these. Okay, so let's keep our tolerance band to the left for this build. I'll place these. Yeah, ideally your flush cutters won't kind of bend the end. Also, putting them in from the top and soldering from the top means that you don't have the temptation to put them all in from the top and then flip them over and then solder them, which often leads to forgetting to solder some legs or things falling out. So that is another reason I do it that way, if you're wondering. There is no right way, there's just whatever you prefer for a lot of these types of tricks and tips. All right, gold band to the left. Franklin says, nice to see a good through-hole project. Yeah, this is, I really like this, and I suspect the other kits that Make It Hackin' has done are also nice. Not a ton of parts. So you can get it done in a reasonable amount of time. I don't know if this show will go longer than usual, I think, if I stick with this. By the way, you can also consider this tacking the legs in place and then flip things over and go at them from the bottom if you want to, if it seems like it's necessary. I don't think it's really necessary in this case. This is not a bad time to flip it over and hack off these leads with my SAD cutters. Okay. Ooh, Make It Hackin' said, I'm going to make a surface mount version for a compact ringer if people don't want to build it. Oh, yes, that would just be like a productized one. That's very cool. Let's see. Why don't we put in the last resistor? It's kind of nice to get things like that out of the way. If you want to do some really involved projects, another thing I've done is, again, just because I like to do Eurorack synthesizer stuff, is find a bill of materials and order a bunch of parts from DigiKey, and then you're responsible for marking everything and putting them into little organized categories and checking things off as you do them, which is also kind of fun. So let's... But yeah, I do, maybe I'll do a surface mount build of something on here sometime, because ultimately, once you get comfortable with and have the techniques for doing surface mount, it is quicker and easier than through hole, just because of not doing all the things you see me doing here, like bending stuff and fitting stuff into holes and trimming things. And okay, so our resistors are in. We can do our, let's do switches. So we've got these little switches here. These I cannot solder from the top. So I will need to bend the legs a little bit before I flip it over. Rufus, I agree. Bands should be in digit order. And definitely don't reverse them. I think I got mine all consistent, self-same at least. So these here, this would be the perfect time for me to actually find my blue tack. Where did I put it? Let's try again real quick to see if I locate the missing blue tack. I might, you know what, I'm just going to check over here real quick. Let's change our camera view for a second while I... Where is the missing blue tack? Nope, not here. Rats. I was sure I'd find it there. Oh well. So let's either tape those or try to bend them a little bit so this, I'm just going to splay them out. Yeah, I think I'm going to do that. Okay, so I'm just reaching under here and pulling the outer leg out a bit. I can show you what I'm doing actually. So I'll hold those in place with my finger. So I'm just going in here. You can use a tool instead of your fingernail if you don't want to ding up your fingernails. Okay, so those are held in place pretty well. I will probably also try to tack it and then hold the switch kind of flush to make sure it's not loose in there. Todd says, this is why I should organize the shop by color. Look for blue tack in the blue section. I think that's the problem. I actually have gray. The blue tack I have is gray and not blue for some reason. That's what's really throwing this off, I bet. So I'm just going to hold that with one finger, hold the solder with the other, and I'm soldering down the middle. Whoa, I'm going to clean that iron tip. Okay, so with one leg soldered, it's a good idea to flip it over and see, okay, this one's a little janky, so I'm going to just heat that and work that into place. So you can see here, I'll heat it and then get it flush. It's best to do this when you just have one leg of something soldered. Okay, those look neat. I like it. So now I'll flip it over and finish. This, by the way, is one of my favorite pan vices for this kind of thing. It's one of the bigger ones, but it has a couple options for how you orient things. It's just solid and sturdy and heavy. You don't need to, you can bolt it down to a bench. You don't need to. It weighs enough to use it like this pretty neatly. Make It Hack and just posted the GitHub on the Discord. Thank you for that. And again, we'll go in with the janky cutters and try to trim that up. Oh my gosh, these are terrible. I have a nice set in my studio workshop inside, but these are, oh my gosh, these are terrible. I'm going to throw these away. That's not the nicest looking job on those. I will finish those off later. Okay, so switches are in place. So it looks like we have a booster for, I'm guessing for voltage, if you're using USB versus battery, and then powering the microcontroller on and off, probably with the enable pin, yeah? Okay, so now we'll put in some buttons. Let's start with this little one here. This is a reset for the microcontroller, I presume. These are great because they, whoops, there goes that little light. They really grab the board, so you can flip it over immediately and solder it from underneath. If you can find it. It's that one right there. Voila. Yeah, they're really not cutters anymore, Grover. They're gnawers. I might as well just ask Lars to gnaw away the leads. So this, now we can, how about do those LEDs, then these switches. So I believe, let me double check my documentation from Make It Hack. Okay, so yellow is the LED 1. So this is going to be, you can see the footprint shows the flat side of the LED, which is, gosh, barely visible on this LED. Someone remind me, that's the ground side, yeah? Short leg. Short leg. I'll do these two and then the power one over there. So again, I'm just reaching underneath this and bending the legs a bit so it stays in place best we can when I flip it over. Again, blue tack or holding it or tape. Any strategies for that? Let's get just a bit of solder on one and then I'll square it up. Okay, again here I'll just tack that, then hold it, heat it again, and then press it up. Oops, oh, that's a mess. So let's flip that over and check. Those look janky, so I'm gonna hold this one and look at it while I... There we go. That popped into place. Back to Discord here so I can see any comments. Ground is flat, thank you. One of these things I never internalize and always need to double check so that I don't just release smoke from the diode. So let's gnaw these off again. Oh my gosh, I swear there's a spot on here where it actually contacts the other side fully. There it is. There's like one good spot on these cutters at this point, because I filed them poorly. All right, so let's do the other LED, why not? So again, short leg, flat side, and this one faces a different direction than the other one, so you just got to pay attention. A lot of larger builds, it's really recommended that you take a break, eat something, try to not do it all at once or you start to get lazy and make mistakes. So, I'm going to ignore all that. Actually, I'll drink some coffee. So I'm going to press that from underneath. It'll be worth a check. That looks pretty good, pretty straight. Sorry, I did not hold that up to the camera for you. Yeah, make it hacking. This is a really good vise. This is, I think, I don't remember if they sell these as two parts, but there's like a big base that just gives it a ton of weight. It's also a good parts holder, depending on what you're working on. And then this piece here, you can see it's got these 3 screws, so that can be just bolted onto something. They have magnet bases, a bunch of other stuff, other ways to mount those. It's got a pretty wide work area too. If you flip this bracket around and go full width, it's like, I don't know, 10, 12-inch board could fit in there. All right, let's take those leads off of there. Looking good. So now let's put the rest of these switches in, and then I'll do that display. It's been a while since I've built a straight up kit like this. A lot of fun. Okay, so these ones, you can usually just kind of manhandle them, but if you want to avoid bending, if you get a little flathead screwdriver, or in this case I'll just use the back end of these tweezers, I'm going to give those legs a little push inward as I press this down, and that helps get that seated really neatly there. You can see these legs have like a little bend to them to grip the board when they go in properly. You just want to be deliberate with those. Make sure they're all... I'm going to push the top ones in first, and then that'll make it a little easier to persuade these bottom ones in. Boop. They generally you can just shove them until they go in, but I have on occasion bent one and been sad. There we go. And don't forget on parts like that to actually solder them. This is something I've done more than one time in life, where there's a part that goes in so solidly you then kind of forget it needs to get soldered, and it works intermittently. I've had that happen with IC sockets, which is can lead to really weird results. Or push them into place, maybe solder the corner pins and then forget. There you can tell I think I was on the ground plane there because that one took forever. Thank you. Someone put a link up for that vise. I don't know if Adafruit sells this or sells it still. I think they did at one point. But check Panavice to see if we're still carrying those. They're a great investment. I have never owned these kinds of sort of hobby vices that are anywhere near the quality of the Panavice ones. I've had a lot of little cheapy ones that are pretty bad. So all buttons, all LEDs, all resistors, boop, boop, boop. So let's put that little display in. This display will have a little bit of it's going to live a little bit up off the surface. So you can cut some foam or something and put it under there if you want before you set it down. You can use some hot glue if you want. What I'll do is probably just take a little bit of this foam that I think maybe this came in. This might have been pressed into here, but I think this came in the kit. And I'm just going to snip a little bit of that off and set that under there. Why not? So I'll cut it in half, and thickness-wise. It down like that. I'll just set that under there. You could come up with a better solution than this, but I'm just gonna, oh, the wind is gonna blow it away. I'm just gonna set that under there. I like these little OLEDs. These, I think that's an OLED, yeah? These show up in a lot of builds of, I think Steve, in fact, okay, you're on, if he's still here, he's got one of those little displays on his OMX27 MIDI sequencer with mechanical key switches. Okay, so that you can see is maybe a little too thick, but what I'll do is compress that board down like that, not the screen, and then solder that into place, and it should be pretty nice. So here's a case again where I'm going to grab a helping hand with my solder in it. Fun, if this reaches far enough, fun skill to have is to also solder left-handed sometimes when that's more convenient. So square is the ground on these, so I'm not going to do that one first. Let that cool before moving on. Okay, 3 pins is good, and I'll do the ground. I don't need to keep holding the board, I think. That. And okay, so Jim Hendrickson found, yeah, the Panavice Multi-Purpose Work Center is in the Adafruit store. It's item 2452. Okay, at this point, I think I'll leave those and, oh gosh, I got that pretty, oh no, I got that a little bit crooked. Ah! All right, so we'll see. This is a pain in the neck. So I've got a little bit of an angle. You can see those legs are like a millimeter off. So it was angled forward a little bit. This is tricky to do without desoldering, to go in and heat up 4 pins like this enough to be able to actually correct that. I've also just bridged 2 of these, so I'll need to get a solder sucker in there and fix that. Oh, okay, so that's pretty good. I got it most of the way corrected. And what I'll do is go in and suck this solder away from here. A wick would be good too if you have that. Yay, here's a solder sucker. This is a really good one. I've had this one for many years now, but it's an Adafruit sold Engineer brand, which is a great brand of stuff. You can get it other places too, but love this solder sucker. It has these little silicon tips, so it doesn't melt like some plastic tips, but it gets a good suction. There we go. So that I will resolder that point, but that means I've no longer got that bridge right there. Woo! Okay. Solved. Chip quick. Oh, that's another really good answer. Yeah. Franklin, thank you. All right, we have our display in place. You know what? I don't like this little foam bit. It is causing more problems than it's worth. I'm going to find my tweezers and pull that out of there. I don't know where my tweezers are. I'll use a little dental pick. Okay, so same thing. I don't like. I have introduced an angle here that I'm unhappy with. That was all folly. So I'm going to go ahead and hold down on the PCB again and heat that. Try this time to avoid bridging things. And just try to be a little more careful. So let's go right here. I'm actually going to try to view it from below a little bit. If I can. Okay, I think I felt that move a little, so take a look. Yeah, it's better. Okay. I'm going to leave the little protective screen on for now, just because I'm still soldering things, and that flux loves to jump up onto screens. It knows about them. So I think the last bit we've got is our Rj11 Jack. And by the way, I think I only have one phone here today that will ring, because I've modified some of those others for other projects. So this one should ring, hopefully. It's possible that it won't. We'll find out. I don't know if I've ever made that one ring since I got it. So this could be a bit anticlimactic. But I promise at some point on this show we will hear a phone ring using this. It's also a really neat kit because it does not have any hard to find parts in it, I don't think. Since you get to provide the feather, you could use a ESP32 feather, I presume. You could use a M4 feather. You could use one of the Bluetooth NRF52840 feathers. Wi-Fi. Starman double-sided foam tape works really well for that. You were absolutely right. That would have been a good move. Okay. So I just want to double check because Make It Hacken said he was going to double check about these wires that don't need to be here. Are they safe to have, or are you going to suggest I disconnect any of those before I try firing that up? I think that, yeah, you tell me if that's a bad idea, because I don't know where some of those are connected in the circuit. Liz says, never seen blue tack before, always white. Yeah, when I was a kid, we always had blue tack for poster putty. But yeah, nowadays, for some reason, it's much more common to find that kind of grayish white stuff. Maybe it just doesn't bleed through to your wall paint as easily. Okay, so extra wires are fine. Okay, good. let's try this then, huh? Let's neaten up some things here a little bit. And we can put some button caps on too. What color order did you put those in? White, yellow. Oh, we've got different color button caps. All right, I'm just going to leave those off for now. Let's take a battery. I'm going to put this to off. I'm going to put this to battery. Now, I think you said maybe the trim pot might need to be adjusted. I can't pull up the PDF over here, so let me know if you think I should get the meter out and test any voltage before we go plug in the phone in. That's my other question. Oh wait, I can get the PDF, can't I? Yeah, let's see. All right, so this board requires you adjust the output voltage with the potentiometer. Test with a multimeter. See output should get around 40 volts DC when power is coming from the USB port. Okay, so let's do that. I'm going to plug in no battery. Switch this to USB. Plug that right like so. Hey, how come my feather, did I get some solder up into the feather header? Doesn't want to go in. I bet I did. Well, it's connected, but it's very lopsided. I think I flowed solder up into this feather header. Whoops. That's a first. Okay, so I'm going to grab a USB-C. I just had one. Where'd it go? Here it is. So I'm going to grab a USB-C to power that feather. Dun dun dun. Getting out a potentiometer, not a potentiometer, a multimeter. Let's take this light and put that over there. So we're looking for AC voltage, is that right? I think we're looking for, would you say 40 volts DC, okay. And that's going to be coming out of that, okay, I see. Yeah, of course, the AC is the motor controller's job, so this will be 40 volts DC. Okay. Yeah, they are low-profile headers. I was probably being silly doing that. It's partly why they aren't all the way down. Whoops. All right. I just unplugged half of the feather, which means that the enable switch came off. Okay, so this will turn on the microcontroller. This is USB power. This is, hopefully we can get a reading from that. So that's interesting. Why is that draining like that? It's gone down to 6 volts. 1.5 or millivolt. That does not. Oh, I'm on AC. Sorry about that. There we go. Okay, so at 20 volts. So I'm going to grab a little flathead for this trim pot. Did I say that? Oh, I already have one on here. Okay. So there's a little trim pot right here. Turn the booster switch on. Okay, yep, we're on. Thank you, Andy Calloway. Saw my meter was set to AC. It's a fun mistake. Okay, so we're at 20, so now I'm going to adjust this little trim pot to the left, so I'm giving it less resistance. and this is a multi-turn trim. So we're at about 29, 30. The meter just put up the danger sign. 30 volts DC is when danger occurs. 36, 7. Okay, that's as far as it wants to go. And let's get boost off. Boost on. 37. Okay. I think that's, I'm not sure why, if you think I should be getting more than that, but 37.35 is where this trim pot is bottoming out. I wonder, do you think I'll get more off of battery? Let's turn this off. I'm going to unplug USB. I'm sure you're screaming at me, don't do that. Let's see. This is also the most dangerous feather. I cracked the battery JST connector shroud, so it's not really keyed anymore, so you've got to be a little careful you put that in properly. So I'm going to switch over to battery. And see what we get. Same. Okay, well, that's probably good. Yeah, so 38 to 40 is what you're seeing. Great. Okay, that looks good. I say let's just try it. So let's get the multimeter out of the way here. I'm actually going to turn off my AC. It is actually a little chilly in here now. Let's clean up a bit, because nothing worse than, in fact, let me turn this off. One thing I will recommend with these kinds of through-hole projects is before you start turning stuff on, just like tap and do this little inspection that you don't have little trimmed leads bridging stuff. It's a really sad way to ruin something, is the trimmings of your through-hole leads are bridging power to ground. Also, another tip is check that you don't have a short between power and ground before you go turning these things on. That was another thing I usually do that I didn't do. Crossing my fingers says make it hackin'. If this doesn't work, I suspect it's this phone here. So I've never tested this yard sale telephone for ringing. I have used it. I think I plugged it into like my voice over IP cable modem-y kind of thing and used it to make and receive a call, but maybe I heard it ring. I'm not sure. Now I'm thinking maybe I did. Dun, dun, dun. Click, satisfying click. Okay, battery, power on, booster. We have a little lovely display, American. Button B, British, and C is single. It's trying. Button A pressed American ring, but it is not ringing this thing. Oh, come on, thing. Let's try USB. Power, in case that battery is not up to the task. Okay, so the microcontroller has power. Power is onto USB. Interesting. There we go. Booster on. Oh, it's trying, but it is not going to do it. I suspect this phone wants more than that. It probably wanted the full 40. I hear crackling. Ooh, it's definitely making a sound. You can hear it. I think it's, let me see if you can hear this. So that is probably the sound of the microphone, or rather the earpiece, cutting in and out because it doesn't blast the sound of the ring through your earpiece. Yeah, Make Hackett says older phones seem to require a higher voltage than others. Why did I toss? I had I had a phone right here. I don't know why I got rid of it. And I don't think this one is actually, I rewired this Lineman's handset, which I don't even think has a bell in it. Yeah, that one won't, that one's not gonna work. Why did I get rid of, I don't think I have any sort of newer phones with me. Okay. Bring, bring. Pretend that we heard a really great ring. I am sorry I didn't test this phone in advance, but I suspect that it probably, this ringer will work with a more modern phone. Do I have anything I can run and grab? I don't think I do. Why? Yeah, I foolishly, I raided some of my older, or not as old phones for some parts for some of my recent projects, and so I don't think I have a phone. Drat, sorry about that. Ring, ring. I'm sure it's trying. So, look on the bottom of the telephone, the volume wheel. Okay. High volume. So this phone, by the way, the volume wheel is like a dampener on the bell. Yeah, I think it just doesn't have the oomph. There's also a chance that, could this one be the reverse sync? I think this one has the little converter box that allows it to work. There's like a rectifier inside of here that was like an add-on when some of these phones came into service to reverse the polarity of it. Oh, why did the feather reset? That's interesting. Drat. Yeah, we can definitely hear it trying to do something. All right. So I will get a phone. I'll get a slightly newer phone, and we'll try that out with that. Yeah, C. Grover asked, does the Lineman's tester have a ringer? I don't think it does. And I think I rewired this to act just as a switch. I pulled it apart, and I don't think I put it back as it was intended. We can try it though. This will be the last thing we try. So I've got probably, trying to think what the best way, yeah, probably the best way to try to connect that is with this and this little Lineman's tester. Now these have these bed of nails things, so we'll see if that works, but I don't know what, I honestly don't know what line on the modular jack here it's trying to ring over. And that's a little tricky to discern from the board. If anyone knows, I don't think it's just like red and black or something as simple as that, honestly. Try the American ring again. Okay, so let's plug this back in. Come on, thing. Okay, you know what? Forget the Lineman's tester, because I really don't think that has a bell or a buzzer or anything in it. I could be wrong. Maybe it clicks. But the one thing I do want to do is open this phone and make sure that it's actually still connected as expected. Let's get a flathead, a larger flathead. Think that it's the middle two, red and green. Okay. So yeah, sorry, this is how you know this is not a cooking show. I did not have this tested and prepared in advance. Yes, be careful with the voltage. Thank you. This is... Okay, so this is the little... I mentioned this phone has a... I'm going to unplug the phone from here. This phone has a little... telephone company added rectifier here to deal with the house wiring or station wiring would have sometimes been reversed. It looks, everything looks intact. I did not mess with any of the wiring in this one. So this is wired as it was. I think this worked. I think I rang this with my home line. So it should work, but it's probably just wanting slightly higher voltage. The one risky thing I'll try is just I'll grab a little piece of plastic and I will try to jump start the little solenoid as it's ringing. So let's plug this in like that. Let's turn it on. There we go. This could also be potentially my header wiring there, right? Oh no, I guess a lot of things wouldn't work if that were the case. Okay, so I'm gonna, so I think, yeah, I can hear it. No, it does not want to kick that solenoid into gear. All right, we'll turn that off. We'll call this only a partial success. I'm gonna unplug this here, and we'll call that. Let me move over here. So yeah, this is off. I'm gonna unplug this. I'll dig into this more and see. I suspect the code is all running right because the OLED was doing its thing and we heard it trying to call, but it just probably doesn't have the oomph for that. Axel Mangus Manson says, can we see the signal on an oscilloscope? Not an oscilloscope. That would be a good idea. Charles Burnford says, do you have a Princess phone? I do not. C. Grover said, just checked some newer butt sets. The little Lineman's handset do have electric ringers in them. Anything else? Could put a step-up transformer between the phone and the circuit. Yes, that's a possibility. We could try to boost that further. I want to control it with an ESP82 or ESP32. Yeah, for sure. And I think if you look, just so you can have some satisfaction, let me find the demo that Make It Hackin' did of this actually working, so you can see it ring. Let me go to our show and tell. And I'll try to find that episode. Can we sort these by date? Or do you happen to know the date you were on? Make It Hackin', that would be helpful. Or let me know if you have that up on your own YouTube. I bet you do. Let's see. Make It Hackin'.
Welcome, hackers. Today, will these 5 hotels...
Videos. Do you have a demo up? It looks like no. All right, if you can send me, or if someone could send me. On last week, it was last week, thank you. I forgot already. Was it really? A lot has happened. Let's go to...
Welcome.
Show and tell. What was last week's show and tell? There would be 3 16, 22. Do I have that right? Siguro said it could be that the GPIO pin signals aren't getting to the motor control. I think it is though, because when I lifted the receiver, I heard it brrrring. So it was. I think it was getting all the way to the phone. That's my suspicion. Show and tell. I must have the date wrong. Was it the 15th? What was last Wednesday? Should have been the 16th. Is that only in our live streams? Show and tell. Yeah, it was 316. Okay, here we go. Here it is.
It's needed.
Lots of voltage, some particular timing. I put this together.
Just arrived this afternoon, so what I have here is feather.
Here we go.
Here. There's kind of like a spot if you do a standoff to put a battery underneath, and you have a few buttons to ring a few different styles or whatever you want. There's some indicator LEDs. Now there's a feather wing breakout. You can do it from USB, or
Hey.
You can put on a battery. I don't think the batteries last too long, depending on the size. That signal is fed into this boost.
US ring.
All right, good. So we've at least gotten some, hopefully some satisfaction in seeing it ring. I will trot out, I'll try to fix that feather header on there, and I'll also trot out some other phones if I can find them. C. Grover said maybe it's just one PWM on the H bridge rather than both. Yeah, I've got some troubleshooting to do. But thanks for, hopefully that was interesting and you learned some things about how I approach putting together a little kit like that. And we will keep you updated. And I think we have well run over our time. That was an hour and 45-minute live stream. So I'm going to get out of here. Thanks everyone so much for stopping by for John Park's Workshop. I will be back next Tuesday with another JP's product pick of the week. And I believe we have Tim tomorrow with a deep dive with Tim, or deep dive with Foamy Guy. If he's around, he can probably answer that question in the chat. Thank you everyone so much. And we will see you next time. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.